Let's do a comprehensive review of Calculus 2. So, Calculus 2 review. We tend to start the course by talking about the area between two curves. So we need the area between y equals x squared minus 4x plus 3 and y equals x minus 1. Now if you check on your graphing calculator or by hand, you'll notice that this looks a little bit like this, and the x minus 1 goes this way, so there's the area we're looking for. We need the line on top, that's on top, and the curve on bottom. The points of intersection here, this is at x equals 1, and this is at x equals 4. Now find that by going x squared minus 4x plus 3 equals x minus 1. Subtract this over, you've got x squared minus 5x plus 4 equals 0, so x minus 4. X minus 1 equals 0, so x equals 4, x equals 1. So my limits of integration are going to be 1 to 4. The top function is the line equation, so that's x minus 1. Then I need to subtract the parabola equation, x squared minus 4x plus 3 dx. So then we can combine and integrate 1 to 4. Let's see here, we've got minus x squared. We've got plus 4x plus 1, so that's plus 5x. Notice how it kind of turns around from here. Then we've got minus 1 minus 3 is minus 4 dx. This, use the reverse power rule. So we've got minus x to the third over 3. Reverse power rule, 5x squared over 2 minus 4x from 1 to 4. Put 4 in here, minus 64 over 3. Put 4 in here, 16 times 5 is 80 over 2, so plus 40. Minus 4 times 4, so minus 16. Subtract, here we've got this 1, minus 1 over 3. We've got 5 over 2, minus 4. So now I've got to do a little combining. I add 1/3 here. I've got minus 63 over 3 plus 40 minus 16, so that is plus 24. And then minus 5/2 and plus 4. This is minus 21 plus 24 plus 4 minus 5/2. So what do we have here? 3 plus 4 is 7, minus 5/2, so that's 14/2 minus 5/2. Looks like we've got 9/2 as our final result. All right, so anyway, just a little bit with the area between two curves. Let's see what else we've got. Here's another one. This one has y equals x squared minus 2x. And y equals minus x to the 4th. So the difference there, graphing that, you might notice it looks kind of like that. That's pretty lazy graph on that, but anyway, if you want to find out where they intersect, set them equal to each other. So x squared minus 2x equals minus x to the 4th. So x to the 4th, add that over here, plus x squared minus 2x equals 0. That's not really all that decent, actually. You can factor out an x, and you get x to the 3rd plus x minus 2 is 0. Now, that's not really all that easy to calculate. It you might notice works really well at 1. 1 plus 1 minus 2. So x equals 1 actually works there. You could try synthetic division. You could try your calculator. You could try a few things there. But anyway, we've got from 0 to 1. The one that is concave down, this one, is on top. So if I do this, I go from 0 to 1. I'm going to take minus x to the 4th and then subtract x squared minus 2x dx. So that's going to give me, the integral of this is minus x to the 5th over 5. Integral of minus x squared is minus x to the 3rd over 3, and then plus x squared from 0 to 1. So what do we have here? We've got minus 1/5, minus 1/3, plus 1, and then minus all these with 0. 0, 0, 0. That's kind of easy, at least. So we've got minus 1/5, minus 1/3, that's minus 3/15, minus 5/15, that's minus 8/15, plus 15/15, so minus 8/15, plus 15/15, 7/15. So there's your positive answer. Area between two curves should always have a positive answer. Now let's check another one. Almost the same idea. This one has y equals x minus 4 and y equals the square root of 2x. So the curve here versus this. So set them equal to each other. X minus 4 is equal to the square root of 2x. We have to square both sides to actually get any work out of that. So we would find that we'd have x squared minus 8x plus 16 is equal to 2x. And so if I subtract the 2x over, I've got x squared minus 10x plus 16 is 0. Okay. Now, one thing about this is it actually is going to be dealt with from 0 to the intersection point. Okay, so 0 is not really an intersection point, but we're going to find the area from 0 to an intersection point. Now, if I do this, I've got x minus, let's see, 8 times 2 is 16, and 8 plus 2 is 10. So x minus 8, x minus 2 is equal to 0. So this would be at x equals 2, x equals 8. Check the work on that. And if you've got 2, then you need to have 2 minus 4 is minus 2. And 2 times 2 is 4, square root of 4 is 2. So minus 2 equals plus 2. That is not correct. And the thing is, it's because we squared both sides. It's not a mistake unless we don't find it. 8. 8 minus 4 is 4. And 2 times 8 is 16. Square root is 4. So that's the only actual intersection. So let's intersect. And we go from 0 to 8 then. The top function just happens to be the curve. So it's square root of 2x, and then subtract x minus 4 dx. To make that easier, I'm going to do this. I'm going to call it 0 to 8. I'm going to say it's square root of 2 times x to the 1/2, then minus x and plus 4, like that. So square root of 2, x to the 3/2, just raise it up 1, divide by the new power, which is times 2/3, then minus x squared over 2 plus 4x, evaluate from 0 to 8. Okay, so 8 to the 3/2. All right, 8 square root of 8 is 2 square roots of 2. So we're going to have this. We're going to have 2 square root of 2 from this, and then 2 square roots of 2 from that, raised to the 3rd, okay, because square root of 8, is 2 square roots of 2, and then multiplied by 2/3. That's pretty involved, right? And then minus x, so minus 8, 8 squared, so minus 64 over 2, so that's minus 32. Then plus 4 times 8, so plus 32. Then we need to subtract all these when you've got 0, and they're all zeros, so that's kind of nice. So what do we have? Let's see. We have got 2, square root of 2. We've got 2 cubed, which is 8. We've got the square root of 2 cubed, which is 2 square roots of 2. And then we've got 2/3. And then we've got 0. So square root of 2 times square root of 2 is 2. 2 times 8 is 16, times 2 is 32, times 2 is 64 over 3. So there's the answer to that one. Let's see what happens next. Let's find the area. So this would be problem 4, I guess. Find the area between y equals ln x and y equals ln 2x from x equal 1 to x equal 5. So ln x, ln 2x. Let's use some algebra here. This one is y equals ln 2 plus ln x, okay? So this one is, ln 2 is like, let's see, it is 0.6913 or 6931, okay? So approximately that, and you're adding it to ln x, so it's a little bit bigger than this one. So this one's on top. So what we're going to do is we're going to, so this one's the top, okay? So I'm going to integrate from 1 to 5, and I'm going to take this guy, ln 2, plus ln x, and then I'm going to subtract the bottom one, dx. Notice how nice that is. That's gone. So all I'm doing is integrating ln 2. So what I get is x ln 2 from 1 to 5. Okay, so 5 ln 2 minus 1 ln 2. So 5 ln 2 minus 1 ln 2 is equal to 4 ln 2. So there's my answer. So that one worked out pretty well. Okay, so let's try some other things here. Let's go to volumes. Number 5. We need the volume of a function. We've got to revolve around the x-axis. So about the x-axis. We can use either disks or shells. We have y equals 1 over the square root of x. We've got y equals 0, x equal 1, and x equals 7. So I need a picture to try to get an idea what I'm doing here. So here is y equals 0, the x-axis. X equal 1 is a vertical line right there. X equals 7, a vertical line right here. 1 over square root of x. Okay, it looks a bit like this. Let's see, x is 1, gives us 1. Okay, x is 2, 1 over square root of 2. You know, so it's kind of dipping down like this, okay? And we've got to spin this guy around here. So I'm going to take disks. I'm going to use disks. Now, if I take a disk, it's going to be like this. It's going to be dx wide, all right? So I've got to have dx. The area of a disk, it's circular, so it is pi r squared. So I'm going to take pi. Now, what's the radius? Well, the radius of this disk is from here to here. That is the y value. Here's the y value. So here is r, and I've got to square it. So pi r squared, and then the thickness is h. Got to go from x is 1 to x is 7. So there's the answer, or the integral that we're working. So this is 1 over x, okay? So we've got to go 1 to 7, 1 over x dx. Well, the integral of 1 over x is the natural log of x, and so natural log of x, and it's done with absolute values. Not that it matters here. So we're going to have what? Pi ln 7, ln of absolute value 7 is the same as ln of 7, minus pi ln 1, but this is 0, so the answer is pi ln 7. Okay, so that's where we're going with that one.